All right, good afternoon. Today, we're going to do a short video on acid-base analysis. Now, acid-base refers to what the pH, and pH means how much hydrogen there is in the blood. It has to do with what the pH level is in our blood. And the pH is really important because certain chemical reactions will only occur within a certain amount of hydrogen ions being available. If the pH is too low or the pH is too high, then the chemical reaction doesn't occur and we die. So it's super, super important. So the body's got this really complicated system to keep our pH normal. And it does this through lots of different things. But the simplistic, as a paramedic, we are concerned with basically two ways. We've got buffers, aka bicarbonate, and then you have respiratory, or we increase the respiratory rate or we decrease the respiratory rate. So how this factors in, I'm going to show you this formula really quick. It's called Lechat's formula, and what it refers to is that we have extra hydrogen ions. The body can combine the hydrogen ions with bicarbonate, which is HCO3 with a negative charge, and the hydrogen's got a positive charge, and it can convert that into H2O and CO2. So then the body we can breathe out or urinate out the water, and we can breathe out the carbon dioxide. So this is a way for our body to buffer too many hydrogen ions by taking some bicarbonate out of reserves and then basically combine it, turn it into water, CO2, breathe out the carbon dioxide. The acid has left the body. So as a paramedic, the very simplistic view is that CO2 is the same as hydrogen, meaning if we make more CO2, it can combine, because this reaction here can go both directions. So if we add a whole bunch of CO2, aka the patient stops breathing, we start building up a bunch of CO2, then CO2 is going to combine with water and it's going to turn into bicarb and hydrogen ions, and the patient will become acidic. Likewise, if our respiratory rate goes up and we breathe out a whole bunch of CO2, the body will recognize that, and then it starts some chemical reactions, and then we're going to turn hydrogen, and we're going to end up with an alkalosis situation. If you breathe out a bunch of CO2, because CO2 is an acid, you breathe out a whole bunch of it, the body becomes more alkalotic. So this is, like I said, the Lechat, I don't know if I'm spelling this right, Lechat. So Lechat's formula. It's the very simplistic view that says hydrogen's an acid and it turns into CO2, so therefore CO2 is also an acid. Don't try to explain to a doctor that hydrogen or CO2 is an acid, because they understand a much more complicated view of acid-base, and they will probably laugh at you. So acid-base, so that's the first thing. Hydrogen and CO2 are related, but either one can be the cause and either one can be the effect. So that's a real key thing. CO2 is not always the cause of acidosis, and acidosis is not always the cause of high CO2. All right, so let's erase this a second. All right, next part of acid-base analysis is the ABG, which stands for Arterial Blood Gas. So this is where the doctor orders an ABG, they take some blood, and then they go over to a machine. So they put the blood into the fancy machine, and it spits out a little piece of paper out the side, and you look at it and it says pH, PaO2, PaCO2, SaO2, and bicarb. And then also base excess. Now, base excess we're not going to talk about here. And the blood gases, the PaO2, the oxygen, the CO2, and the SaO2, I'm going to tell you what the normal numbers are, but those really factor into other videos. We're just going to talk about the acid-base part of it. So pH normal range is 7. So normal range on the acid base is 7.35 to 7.45. Technically speaking, totally normal would be 7.4. But again, that normal range is 7.35 to 7.45. PaO2, so this is how much oxygen is dissolved in that blood sample. And the normal range for this is 80 to 100 millimeters of mercury. So this is what's dissolved in the blood, floating around in the plasma. SaO2 is how much oxygen is attached to the red blood cells. This is the same as pulse ox. And so that you're looking for greater than 95%. The PaCO2, this is how much carbon dioxide is dissolved in the blood. In an arterial sample, it's going to be 35 to 45 millimeters of mercury. I always remember this because it's the same as the pH is, just without the 7 in front of it. So 7.35, 7.4, 35 to 45. PaO2, I always kind of remember that in school I want to get all A's and B's. So you got to get a 80% or higher to get A's and B's. 95%, so that's our A+ score. And then bicarb, normal range is 22 to 26. And remember I said that the doctor over here, the MD, ordered this ABG to be drawn. Well, most doctors go to medical school between the ages of 22 and 26. They get out of college after 4 years, then go to med school for 4 years. So that's how I remember what the normal range of bicarb is. And then base excess is between -2 to +3 in this little range here. And like I said, we're not going to cover base excess in this. All I want to talk about is if I give you a pH, if I give you a set of ABGs, can you identify whether it's a acidosis, an alkalosis, whether it's metabolic or respiratory? So here goes. Most of these numbers you can throw out. If you want to know whether it's an acidosis or alkalosis, metabolic or respiratory, you got to look at the pH and you look at the bicarb. So here's how it works. So our body, I'm going to draw this guy here. So we got arms, torso, legs. All right. So our lungs are up here, kind of by the arms, right? And our lungs are pinkish purple. And so the lungs are responsible for respiratory causes of acidosis or alkalosis. So if you think about this, this makes sense, right? If you've got a patient who's not breathing because they're in cardiac arrest, they're not getting rid of CO2 out of the body. And that Le Chatelier's formula says if we add a whole bunch of carbon dioxide, eventually that'll turn into hydrogen, which is an acid. So not breathing or not breathing enough or not getting that carbon dioxide out causes respiratory acidosis. Respiratory alkalosis, on the other hand, is breathing out too much carbon dioxide. And we see this with patients suffering from anxiety and hyperventilation syndrome. They breathe far, far too many times. They breathe out a bunch of CO2, which then lowers the amount of hydrogen. That makes them alkalotic. So their pH is higher than 7.45. Then over here, down in the abdomen, okay, so in the abdomen we have the liver, the pancreas, the stomach, the intestines, the kidneys, all these organs down there in the abdomen, and I'm just going to count the kidneys as being in the abdomen. So you've got all of these parts of our, the main core of the body, these all are going to be metabolic causes of either acidosis or alkalosis. So you could probably name a few of them. So you've got something like diabetic ketoacidosis. This is a problem with pancreas and liver. You've got alcoholic ketoacidosis. You've got a situation with kidney problems. You've got like the body making too much CO2, like from a lactic acid buildup. So you have a lactic acidosis. These are all coming from the body somewhere. And so I always remember that body causes are going to be reflected in that bicarb score. So if you want to know if the cause of the acidosis or the alkalosis is metabolic, the bicarb is going to be different. So we got metabolic acidosis. You're going to have your pH is going to be down, and your bicarb is also going to be down. So I always think of it as we've got an acidosis down here in the abdomen, and that's where all the bicarb is at, because bicarb's in the body. It's not a respiratory thing. So bicarb's in the body, and then there's an acidosis going on. The bicarb's trying to fight the acidosis, right? It's trying to fix the acid because it's a base, it's a buffer. So it's trying to fix the acidosis. So if our pH is still low and our bicarb level has gone low, pH low, bicarb low, then the pH low means acidosis, and the bicarb low meaning it's got to be a metabolic cause, something down here in the muscles or in the stomach, versus that respiratory and respiratory acidosis and alkalosis. And then you have the metabolic alkalosis. So this, we're going to have a pH. It's an alkalosis. That means the pH is up. And then the bicarb is also up. So this would be some sort of problem down here in the abdomen. I think one of the examples that I was taught in school was someone who eats way too many Tums. Tums to Tums. Those are basically all bicarb. It's bicarb and a little bit of flavor. So we've put too much bicarb into the body, causing a metabolic alkalosis, or the administration of too much sodium bicarb into a vein that goes in the body, or some sort of weird problem where a person's like puking too much and they're vomiting out all their stomach acid, making them alkalotic because their body lost a bunch of acid. So again, if the pH and the bicarb move together, they both go up or they both go down, that's a metabolic cause. If they don't move together, just the pH is high or the pH is low, but bicarb is either opposite or normal, then that's a respiratory cause. So if you haven't written down, write down what these normal values are for the ABG. I'm going to erase this screen in a second and give you a few practice problems. Okay, here goes with a few practice problems. So, acid, base, practice. All right, so number 1, pH 7.3, bicarb 23. Number 2, pH 7.3, bicarb 17. Number 3, pH 7.6, bicarb 24. pH 7.6, bicarb 40. Number 5, pH 7.1, bicarb of 18. Number 6, pH 7.1, bicarb of 22. Okay, so let's go over the answers to these. So again, we said if the pH and the bicarb are either both high or both low, it's metabolic. And if they don't both go up or both go down together, then it's a respiratory. All right, so on this one, we've got a pH of 7.3, so that's low. And a bicarb of 22. Oh, let's write our reference values. Remember, so its pH is 7.35, 7.45, and then the bicarb is 22 to 26. So in this case, pH is low, bicarb is normal. They did not move together, so this is respiratory acidosis. Next one, 7.3, that's low, so it's an acidosis. So I'm going to write that down right now. Acidosis. And then the bicarb of 17, well, that's low, so this is metabolic. Next one here, pH is 7.6, well, that's high, so this is alkalosis. The bicarb of 24, that's normal, so this is a respiratory alkalosis because the pH went up, but the bicarb stayed the same. Down, down. All right, pH is 7.6, alkalosis. And bicarb is 40, so this went up, and this went up, so it's metabolic. Next one here, pH is 7.1, well, that's down, so that's acidosis. And then the bicarb 18, that's also down, so this is a metabolic acidosis. And then number 6 here, pH 7.1, that's acidosis. Bicarb of 22, that's normal, so it's respiratory. So this is, like I said, the very simple way of doing acid-base, looking at an ABG value and determining right off the bat, is it respiratory or is it a metabolic cause? I'm going to leave you with one little tidbit for this video. And so that tidbit is this. If your patient has a respiratory acidosis, so we talked about before I erased the screen that a respiratory acidosis means they've got way too much carbon dioxide, and all that extra carbon dioxide is turning into hydrogen ions. And you wanted to fix this respiratory acidosis. What's the best way to do that? They're getting acidotic because they're inadequately ventilating. They're not getting the CO2 out of their body. So some people will instantly say, well, sorry about that. If the patient is acidotic, then we have to give them a base. And if you open up your paramedic drug box, there's one base in there. Sodium bicarb. And you just go, see, my patient's acidotic. I'm going to give them a base. I'm going to fix the problem. Boom. Start slamming in sodium bicarb into them. Well, sodium bicarb, we're just going to look at the formula for that. So it's NaHCO3, sodium and bicarb, and we want that to combine with hydrogen ions. This is a minus, this is a plus, and they'll turn into sodium by itself plus water plus carbon dioxide. So if you count them out, you got 2 hydrogens over here, you got the 3 oxygens, the 1 sodium, the 1 sodium, the 1 carbon, the 1 carbon. They balance each other out. So we give sodium bicarb. It combines with a bunch of hydrogen ions in the blood to turn into sodium, water, and CO2. So if your patient is acidotic because of a respiratory acidosis, they have too much carbon dioxide in their system. That's why they're acidotic. They're not breathing enough. And you start an IV and you give them a bunch of sodium bicarb, you're literally saying, I want to create more CO2 over here. And CO2 is the root of the problem that you're trying to fix. I don't think for respiratory acidosis, sodium bicarb is doing your patient any favors. If they're not breathing enough, we have a solution for that. You can intubate, or you can use a BVM, or like I said, you intubate and you put them on a ventilator. So if they've got too much acid and too much CO2 in their system, go ahead and fix it. I'm not saying don't take care of your patient. I'm just making the argument that sodium bicarb is not the way you fix a respiratory problem. Going back to that picture, respiratory problems we fix with fixing their respiratories, either more or less. Metabolic problems down there in the body, problems of too much or not enough bicarb, we need to go to the source to fix those. So that's the end of the video. Thanks a lot. Have a great day.